Hi everyone, we've got another video for you. We got the video and then the book problems, and if you can get them to me by midnight, before midnight, well, Thursday at 11:59 p.m. is probably what I should say. And we're talking about, we went double angle, now we're doing half angle trig formulas. And I want to show you how to do a few of examples. But we have these identities you'll need to get written down. The sine of u over 2 equals positive or negative 1 minus the cosine of u divided by 2. And these positive or negatives depend on where the u over 2 angle is. If it's in the first quadrant and your sine, it's positive. If it's in the second quadrant and your sine, it's positive. If it's in third or fourth quadrants, it's negative. And then cosine, if u over 2 is in the first or fourth quadrant, it's positive. If it's in the second or third quadrant, it's negative. So it just depends on where that lies. So cosine of u over 2 is the same as sine, except instead of a minus here, you got a plus here. Then you've got two identities here for tangent. 1 minus cosine of u over sine of u, or sine of u over 1 plus cosine of u. Now, I've got an example here. We're going to find the exact values of, and the first one I chose. Now, when you do the homework, I just wrote a little note here. I got two of these problems. They're going to want you to do sine, cosine, and tangent of this. They would have you do sine, cosine, and tangent of this angle, and then they'd have to do sine, cosine, tangent of that angle. I'm just going to have you do a couple of them, but I'm just going to do one of each, just show each one in use here for our notes. Now, the sine of 112 degrees, 30 minutes. Yes, those are back. Now, what I want you to do, in 30 minutes, remember, is 30/60ths of a degree, and 30/60ths is 1/2. So this is the sine of 112.5 degrees. And then we're doing half angles here. So this would be half of what number? Well, if I double that, I get 225 degrees. Okay, now I've got a formula up here that I'm going to be able to use. And 225, we're getting exact values, so that means unit circle stuff. 225 is on our unit circle, so we're going to be able to deal with that. Well, what happens when we do this? The sine of 225 degrees over 2, and actually 112.5 degrees is in the second quadrant, so this is going to be positive for sine. So I'm going to take 1 minus the cosine of 225 degrees over 2, and that's 1 minus, now 225. Let's take a look at 225 real quick. There's 1/8. That's the half mark in the third quadrant. That is the square root of 2 over 2, square root of 2 over 2, and they're both negative. So the cosine is negative square root of 2 over 2, and then we still have this part that's over 2. Now, I'm going to get one fraction on the top, so I'm going to make 1 be 2 over 2, and then a minus and a negative is plus. Radical 2 over 2, we still have a 2 there. Now, the one fraction on the top is 2 plus radical 2 over 2. Now, that is over 2 here. And if I multiply 2 by a half, so I get this to be a little less messy, that cancels. So now I'm looking at square root of 2 plus the square root of 2 times 1. This is all under the square root. Is 2 plus square root of 2, and then 2 times 2 is 4. Now I'm going to take a moment here and, whoops, I'm going to write the numerator and denominator with their own radicals. So I got square root of 2 plus radical 2 over the square root of 4. And we're going for exact values. We have a radical under a radical, which looks a little crazy, but it is in the numerator. We have rationalized the denominator, because square root of 4 is 2. So that's what we're going to call the final answer there. And that's for the sine. That's for the first one. Now for the second one, I'm going to do the cosine of 165 degrees. All right. So what would I divide by 2 to get 165? If you're saying 330 degrees, you are correct, and that is on the unit circle. And when I use the identity for cosine, now 165 is in the second quadrant. So cosine in the second quadrant is negative. So that's why we're going to use a negative there. And I'm going to go 1 plus the cosine of 330 degrees over 2. And what's that give me? That is negative square root of 1 plus, all right, let's think where 330 is. It's right here, and we're doing cosine, so the x-coordinate is the square root of 3 over 2, and that's over 2. And I'm going to write 1 as, this 1 right here is 2 over 2, so that I can get a common denominator and put that together. And that's over 2. So it's a square root, and remember it's negative. I'm talking to myself, not you. And I got 2 plus radical 3 over 2 over 2. Let me take that by a half and take it by a half up here. And that's basically gone. So 2 plus, it's negative right here. 2 plus radical 3, and 2 times 2 is 4. Multiply the top by 1, the bottom by 2 times 2 to get 4. Into 2, so it's negative here, square root of 2 plus square root of 3 over the square root of 4. And my son decided that wasn't important, so he's not going to answer the phone. When I simplify, I think I'm done. I think that's it. Now, I do have one more problem to do. Let me get, I don't have room on this page, so I'm going to make room to do, what, tangent of 7 pi over 12. Where are we here? Now this time, instead of dividing by 2, I'm going to take half. And that'd be tangent of 1/2. Now, I would need to multiply by 6 to get 12, right? 2 times 6 and then 7 pi up here. So this is a half angle, or divided by 2. So either way you look at it, it's a little easier when you have the radians here with the fractions to use half instead of dividing by 2. And when I look at this, I think I'll just use the first one. I can use, it doesn't matter, I can use either one. I'm just going to use the first one and take 1 minus the cosine of 7 pi over 6. That's what we're taking half of when we put these in, over the sine of 7 pi over 6. And I'm pretty sure if you look at your unit circle, you're going to find that like right here. Here's 6 pi over 6, 7 pi over 6. The x-coordinate is negative radical 3 over 2, and the y-coordinate is negative 1/2. So that's the sine, or that's the cosine, and that's the sine. So I got 1 minus negative radical 3 over 2 over 1 minus negative 1/2. No, that's not 1 minus. There's no 1 minus there. It's just negative 1/2. Okay. I'm going to do the 2 over 2 thing here. And then minus and a negative is plus square root of 3 over 2. So here's my 1, and then the minus and the negative, and this is over negative 1/2. So I got 2 plus square root of 3 over 2 over negative 1/2, and I multiply that by negative 2 over 1. And that's negative 2 times 2 plus radical 3. And that's over 2. Those 2's cancel, and my final answer, let me distribute that negative, is negative 2 minus the square root of 3. And that's for tangent of 7 pi over 12. All right, well, that is done. Let's try this example, number 2 here. It says find the sine of u over 2, cosine of u over 2, and tangent of u over 2, given that the tangent of u is negative 3/4 and u is in the, take a guess at the quadrant. If you said second, you are correct. Let's take a good look at that. It is in the second quadrant. So that means the x is negative. That's sine over cosine, so it's y over x. So let's go here and then up 3. We're to here. And then we'll put our theta right there. This is 3. This is negative 4. I think we've done the Pythagorean theorem enough to know that that's going to be 5. So we know that the sine of u is opposite over hypotenuse, which is 3/5. We know that the cosine of u is adjacent over hypotenuse, which is negative 4/5. And we already have opposite over adjacent. We already have the tangent right there. So we are going to find the sine of u over 2. Now, when you take half of this angle here, and this is actually the u angle, when you take half of that, you're going to be in the first quadrant. So the sine of u over 2 and the cosine of u over 2 are going to be positive. And the tangent of u over 2 is also going to be positive, but that doesn't matter. That'll be taken care of. You don't need to consider that. Now, sine of u over 2, if I recall, is 1 minus cosine of u over 2. No, 1 minus cosine of u over 2. And the cosine of u I've already done. It's 1 minus negative 4/5 over 2. And then that's 5/5 for 1 plus 4/5, that double negative, over 2. And what are we looking at? We are looking at the square root of 9/5 over 2. Take half on the bottom, get rid of the bottom, and I got the square root of 9/10, which is the square root of 9 over square root of 10, which is 3 over the square root of 10, and rationalize that denominator, and I'm looking at 3 radical 10 over 10. So that's the sine of u over 2. The cosine of u over 2 is square root of 1 plus cosine of u. I'm putting -4/5 for cosine of u because we kind of looked at some of that already. And then over 2. So we're looking at 5/5 plus -4/5 over 2, square root of 1/5 over 2. If I take by half and by half, it looks like I got the square root of 1/10 here, which is the square root of 1 over the square root of 10, which is 1 over square root of 10, and let's rationalize the denominator, and I'm looking at the square root of 10 over 10. So for cosine of u over 2. And for tangent, we do have an identity for the tangent. I'm not going to use it because I have the sine and the cosine of u over 2. So the tangent of u over 2 is the sine of u over 2, which is 3 radical 10 over 10, over the cosine of u over 2, which is radical 10 over 10. If I multiply this by 10 over radical 10, and multiply this by 10 over radical 10, the radical 10s will cancel, the 10s will cancel, and we are left with a big old 3 for that one. And I kind of ran out of room there, didn't I? All right, one more problem. I'm solving cosine of x over 2 minus sine of x equals 0. And I'm just going to solve it in the interval from 0 to 2 pi. And let's get this identity so that we have it in terms of cosine of x. And the cosine of x over 2 is positive or negative, and that's going to cause a problem here, 1 plus cosine of x over 2 minus sine of x equals 0. All right, I'm going to do something here. I'm going to add sine of x to both sides. I'm solving this equation, and so I've got plus or minus 1 plus square root of 1 plus cosine x over 2 equals sine of x. And now I want that radical going, so I'm going to square. So it doesn't matter, positive or negative, we're going to get the same thing. I'm going to square each side here. Square and radical cancel out. Positive times positive is positive, negative times negative is positive. So I have 1 plus cosine x over 2 equals sine squared x. I'm going to do one more thing here. And this is what I'm going to do. If you remember, sine squared x plus cosine squared x is equal to 1. And if I subtract cosine squared x from both sides here, I got sine squared x equals 1 minus cosine squared x. Now I got everything in terms of cosine. And here I got 1 plus cosine of x over 2. Let me kind of draw a little barrier there. And I don't like this 2 here. So I'm going to multiply both sides by 2. And that'll cancel. So 1 plus cosine x equals 2 minus 2 cosine squared x. This one it looks like is 1. I'm going to have to get on. I'm going to take all this, add the opposite of this stuff, and put it over here. So I'm going to subtract 2 from both sides. And I got negative 1 plus cosine x equals negative 2 cosine squared x. All right, I've run out of room, so I'm going to keep going right here. Oh, I got negative 1 plus cosine x equals negative 2 cosine squared x. I'm going to add 2 cosine squared x. And I got 0 here. And I've got 2 cosine squared x plus cosine x minus 1 equals 0. Alright, time to factor. If I do 2u squared plus u minus 1, if you don't want to deal with the cosine x as your unknown part, just put u's, and then we'll put cosine x back when we get this factored. Alright, well, what multiplies to 2 times negative? What multiplies to negative 2 and adds to 1? I think 2 and negative 1 do that. So 2u squared plus 2u minus 1u minus 1. Let me factor out a 2u here, and that's 2u, or no, just u plus 1. And let's factor out a negative 1 here, and that's u plus 1. So 2u minus 1 times u plus 1. Alright, so when I put cosine x into place, I got 2 cosine x minus 1 times cosine x plus 1 equals 0. And now the zero product property, we take 2 cosine x minus 1 equals 0, or cosine x plus 1 equals 0. Add 1, I got 2 cosine x equals 1. Divide by 2, I got cosine of x equals 1/2. Alright, where is the cosine of x equal to 1/2? Right there, looks to me, and right there. I'm going to use radians. This is pi over 3, and I think this is 5 pi over 3. So x equals pi over 3 and 5 pi over 3. We don't need the 2n pi because early on it said the interval was just go from 0 to 2 pi. You don't have to keep going around the circle. Now here, cosine of x equals negative 1. So with this, where's negative 1? Negative 1's right here. We get pi for that one. Alright, those are our 3 solutions in this interval. Alright, now your assignment is from page 548, number 35, number 38, 39, 41, 42, 43, then do 45 and 46. It is due at 11:59 p.m. on Thursday, April 2nd. All right, I look forward to hearing from you. And I do miss you guys terribly, and I just want to wish you all of God's blessings and that you're safe and healthy and that it'll stay that way. Take care.